This conference is being recorded. Only the main conference is recorded.
Good morning, everyone, and welcome to the Underground Safety Board's GIS Committee GIS Workshop. We would like to begin by acknowledging that we gather today on the ancestral homelands of the Nisenan people. Sacramento was a gathering place for many local tribes who have lived throughout the Central Valley and the foothills for generations, and were the original stewards of this land. We would like to acknowledge the Southern Maidu people to the north, the Valley and the Plains Miwok and Miwok peoples to the south of the American River, and the Patwin and Wintun peoples to the west of the Sacramento River. Please join me in expressing our deepest respect and gratitude for our Indigenous neighbors and for their enduring care and protection of our shared land and waterways. So today, there's many of you in person today. This is great. So because we're in person and yesterday was a great shakeout, let's review the evacuation route. So if you guys will look at the little PowerPoint presentation, in the event of an evacuation, proceed out the doors in the back of the room, take a left in the atrium, past the restrooms, and use the P Street doors to exit the building. There are stairs and a ramp for use outside of the door. Our assembly point is across the street in Roosevelt Park. All right, so a couple things. Welcome again. Since we are in person, and you guys are all sitting so far, so I encourage you to sit close. This is supposed to be a workshop, it's supposed to be fun. We're supposed to all share our opinions. So if you feel compelled, if the spirit of GIS moves you, please come closer so I can see you much better. All right. So if you would like to speak in person, those attending, you'll just walk up to the podium after you sit closer, and you'll go ahead and turn on there's a little button there, just turn it on, make sure your mic is green so they can hear you online. And for those of you, the 61 of you, oh my goodness, the 61 of you attending on the webinar who wish to provide public comments, you can go ahead and press the raise hand button or dial #2, and then you'll be placed into queue. So then when we call your name, you'll be able to unmute yourself and provide your comments. All right, so nobody moved. I'm very sad. I hope you guys feel compelled by GIS to move forward. So just as a reminder, my name is Amparo Munoz. I am Chair Munoz, and along with Member Voss, we are the board's GIS committee. We have worked with staff to develop discussion topics related to geographic information systems, lovingly called GIS, and we're looking forward to hearing your opinions and thoughts today. Our topic of discussion will include map accuracy and use of GIS for asset management, record keeping, and for damage prevention. And I just want to take a moment on that one, damage prevention. Our entire board is about safety, and each one of you are here today because you did the job safely. So we really want to know your opinion. How did you do this? How did you make this successful? You are the heart of why we're here today. We want to make all of our work safe, and so we all get home to our loved ones. I'd like to share some background in the Underground Safety Board. The California Underground Safety Board was created by the Dig Safe Act of 2016 to investigate accidents, develop excavation safety standards, and coordinate education and outreach programs. It seeks to facilitate communication between excavators and operators of subsurface installations, determining the root cause of accidental dig-ins, and enforce California's Dig Safe Act. And today you're in a safe space, so I'm hoping we have lots of representatives from all different areas. And again, we really need your opinion because the objective of today is to make sure everyone gets home. One of the board's strategic objectives is to improve accessibility of buried structures and infrastructure location and knowledge. So the California Government Code 42163A5 states, commencing January 1st, 2023, all new subsurface installations shall be mapped using GIS and maintained as permanent records of the operator. So many of us do that already, and you're probably wondering, so why are we here? Well, today's goal is to learn from operators, from all of you, and excavators about their experience using GIS for mapping and record keeping. So the board will use comments received today during this workshop to develop regulations. So you guys are going to be a part of how we move forward together and how we protect the people of California. And with that, I hand it over to Member Voss for his introductory statements.
Good morning, everyone, and welcome here to this GIS committee meeting. And we're really looking forward to all the comments that you have today. This is a big topic. I've come to appreciate when regulations are written, in this case, it's a little vague. That's good because it gives everybody, stakeholders in particular, a chance to weigh in on how the board in this case will implement regulations and hopefully come up with regulations that everybody can live by that are reasonable, right? Because it's easy to make laws, right? But to implement them and enforce them, and do they make sense? Can be a challenge at times. So we have an opportunity here today to give us some input to help guide us and the board to form those regulations that we can all live with. I'd like to thank staff, Mignon Marks and Tiffany Nguyen for their efforts here in putting all these documents together. And so again, thank you for your efforts there. And with that, I turn that back over to you, Chairman Munoz.
All right, well, thank you. Okay, so I'm taking, if you have one of these agendas on you, I'm going to take this a little bit out of order. And the reason why is because this whole thing starts with asset management. So we're going to focus on section called 3, GIS for asset management record keeping. So the first discussion topic is, how do you use asset management? Do you use GIS to track your assets? So there's a few questions in there, so if you guys could just review those, but I want to take it through the design, the bid, and the build process, since all of you are from different aspects and different areas of the entire process. If you use GIS, if you use drawings, the as-built for the design process, how does that translate to GIS? If you're using in the bid, do you require that when someone bids on this project that they also include GIS? And then in the build process, how do you verify, or do you verify the GIS or other asset management strategies? So if you guys could just take a quick second to look at the questions. I'm going to kind of go through a few of them. But yes, line up if you guys want. I said get close. So you guys have the front row right here is all available. So if you guys could just go ahead and come up. Take a few seconds to review the questions. And for those of you online, Amber, is it possible to flip to those or to that section? Okay, perfect. Thank you. She's so good. All right. So I guess the first question we can go over is, how does GIS fit into your organization's overall asset management program? Is GIS the system of record? I see heads nodding. Come on down. The price is right.
All right, I'll see if I can't crack the seal and start it off for you.
Thank you.
Chairman Munoz. So Steve Kleber with PG&E. I am the manager for our damage prevention and compliance groups. For asset management, most of our assets are managed for asset management in SAP, so outside of GIS. I am certainly not the GIS expert for our company. I have asked for a couple of our folks that are GIS experts to attend, and they should be on virtually as well. So there may be some folks on the call that are happy, hopefully, to jump in and rescue me in the event that I'm struggling with explaining some of the aspects of it. But we use SAP for asset management. So essentially, if there is a maintenance plan, the asset itself is logged in SAP, and the different attributes and maintenance plan are built around that asset in SAP. We use GIS for locational information and, of course, some attributes as well to make them available to a wider audience based off of locational data rather than having to search through the nebulous asset management plan. So from a system of record standpoint, SAP is our system of record on the asset, but locational data is stored within in the GIS. We're also able to look at specific attributes informationally in GIS, but as far as system of record, asset management is done through SAP.
So there are some other questions in here. What other systems do you use? Does your organization use as-built prior to it? And again, kind of frame this in the design, bid, build. If you have all this, when does it get into your different systems for asset management structure? If you can add some of that. And I guess maybe I'm putting you on the spot because you come into everything, but so how do you harmonize it, I guess? And if your colleagues are on the line, if they want to raise their hand and chime in, how do you harmonize all of that information?
Well, So for us, they're for two separate purposes. One is asset knowledge and the maintenance of the record itself and your knowledge of the asset from an asset management standpoint, and the other is locationally based. So GIS supports us in many ways, and I'll speak specifically in the gas operations field. In the event of a damage, whether it's a line strike or significant leak, the GIS tool is what our operations center will use to develop a plan to send out to the team that if you need to control this uncontrolled release of gas, here are some zone valves that you can turn. This is the operation, and assist in drafting a clearance for this is how we are safely going to turn this off, and give them different scenarios that not only could you operate these valves, but the gas flows bidirectionally in some areas and it's a one-way feed in others. So they use the GIS data in the way that it's mapped out to be able to provide them with an emergency response and then also restoration efforts on the back end of that. A recent example was a damage that happened in the city of San Francisco, and it resulted in significant customer outages, in excess of 600 customers at the end. And in restoring gas to those customers, you first have to shut off the gas. So knowing where all of those customers are at, and we use GIS in combination with other records to verify that we have identified all of those customers that need to be shut off. So then we can verify that the system will hold pressure, that there are no existing leaks, and then begin to restore pressure on that. So the GIS system allows folks in the field to be able to communicate effectively with our operations center in knowing what the restoration plan looks like and helping to communicate out and keep our customers safe as well. And of course, that's just two aspects between the operations center and the folks in the field. When it comes to communication with customers as well, having the knowledge and being able to visualize where all of your assets are at on a meeting and say, this is who we're going to talk to, this is the area that's affected. The visuals of that become very important for us as well.
Okay. Awesome, thank you.
Any additional? Was that enough to start the conversation?
That was a lot to start the conversation. I'm seeing a lot of people looking in very engaged, so I should see a line starting to form behind you. Who's next? It's not too often that the state of California wants your opinion to help write regulations or policies, right? So come on down.
Excuse me, Sarah, I'm sorry. Could you hit the button to turn?
I turned it off.
Oh, I even tried to test, and I completely missed it.
Okay.
I probably didn't set you up. It was awesome.
I'll remember that. I'll remember that. I'm just kidding. I'll start over. So I'm Sierra Scriven with the City of West Sacramento, and we use CMMS for our asset management primarily. Sometimes it consumes GIS services, especially in the case of our utilities, our subsurface utilities, but we use CMMS mostly because the work order management system is pretty good through there. What was the second question you guys had?
I think one of the things that I kind of want to frame this is in the design, bid, build, and I'm going to tell you why, because a lot of these questions are gearing to like, when do you say, okay, I'm going to GIS this? Is it in the design? Is it in the bidding process that you require GISing? Is it in the build process? Where is that happening, and how are you managing the assets from the time that you want to design your project to the time it's ready to roll?
Right. That's actually a topic that has come up in our organization a lot lately, and realizing that we need to get involved in the process a little sooner because we have deliverables that we ask from our contractors. Usually we'll ask for CAD deliverables for where things are spatially, and we'll check those. And we need time in the process to check and make sure that they're actually in the correct location before moving on to the next steps and kind of like losing leverage with contractors. So that's something that we're trying to talk to our inspection team, because we do in-house inspections, to try and make sure that it's happening earlier in the process. So I wouldn't say planning. It's more so in the design is when we're asking for them, and then build is when we find out if they actually get placed where they're planned to be. And moving on from the build stage, we have to have already gone and had our back and forth with the contractors.
So I'm going to ask, so you tell me a little bit more about that. So for example, if this was Sierra's world, tell me what would be the ideal, the best practice. How would this be best? And everyone think about this, because this is your time. You get to tell me what would be the best way. If you're the contractor, if you're the one bidding on this, when would be the best time to know when we are going to marry our asset management, our GIS? Go ahead.
Well, I'm not sure if this is exactly what you're asking, but in my world, I would love if I actually had a GIS file deliverable instead of like a drawing file. But ideally, you want to know from the contractor's perspective or from our organization?
Either. It's your world right now.
Okay. So I previously worked for a consulting, like an engineering AEC company, and then now I work for, on the other side of the fence, for the government. And I would say that when you're bidding on something is when you want to know what the required deliverables would be. And if not, then shortly after, because if you're an organization that doesn't have GIS or high precision data capabilities, and then you bid on something and win it, and then now you have to find somebody else to subcontract in for that. So I would say that if you're asking for spatial data deliverables, you should put that out in the beginning before people are even bidding.
Okay, awesome. Okay. All right. There's a couple other things. You talked about this. You mentioned this. Does currently your as-built specifications, are they in line with the standards for 7522?
You know, that was the one question that I didn't hear back from my engineering team in time to have prepared. So I don't want to misspeak on that, and I'm afraid I can't answer.
You have all your friends in the room. Anybody else want to
I'm going to take a seat. Anyone else can come up now.
Okay. All right. We talked about... Yeah. So, can you see if there's anybody... Oh, look at that. Michael Worster raised his hand.
Hello, Michael Worster. Some of you know me, but I will speak on behalf of a company I used to work for, so I can tell you how their process worked from 2019 back. I can't speak of how they do it now, but from what I do know, their systems were so embedded that they probably not have changed. So I'm trying to answer some of your basic questions of the process of creating a drawing and as-built and getting bids and all the way through. Everything they do is ArcGIS based. But the main problem is that the lat longs are not accurate. Obviously, moving forward, I think they will be if they have to GIS each new install. They already have a system built for it. So their assets management is an internally built system that's tied in. So when you just link onto a lat long and a type of asset, then it goes to their own database management to pull up details about it. So when they draw as-built, they build them off of the ArcGIS, and you run it through their own CAD programs for bid. And then when things are placed back, previously, there was no GIS confirmation of the assets being placed. It was more of inspection to see that the endpoints were met and tested good as far as the communication cable itself. And moving forward with the new law, I think they're going to start to, well, they have to, maybe post-inspect or have the contractors post-inspect with GIS, since it's the requirement. And they're already built to have that plugged directly into their maps. So from repair to cable locates to anything like that, they would have an accurate lat long moving forward with the new stuff. But like I said, the old stuff isn't. So they base around ArcGIS and lat longs. They've always done that. Distances are critical for communication lines, so that's one of the reasons why they do it. So 1,000 feet is not okay if it's really 1,100. So that's why they built upon ArcGIS, and they use it nationally or internationally as well, the same format, and just simple lat long. It's not a lot of complicated data. So just to answer your questions, that's where that was.
Thank you. And since you brought up lat long and distance, can you tell me a little bit more? Because you were talking about you started to mention your idea of precision for distance. Can you talk a little bit more about that? Again, this is your world today, so
Right.
just tell me your best ideas.
Well, previously copper phone cable was very sensitive to distance. Your design of your copper cables, what you chose, especially when we're looking at older digital lines, it was very critical to get down to the foot. So the length of the cable, the length of the line was a critical thing, and that's why they went to GIS. But unfortunately, the placement, you could be on the north side of the street or the south side of the street, as long as you got the distance necessary, the way it was designed, then that was okay. So when we get to damage prevention, it made it very difficult. But moving forward into the world of fiber doesn't care about the distance. And that's not just the incumbent telephone companies, but every little mini fiber company coming into the program, Wave, Sonic, Charter, everybody's placing fiber now throughout the state with the infrastructure bill that's pushing. Obviously, California is going to start doing their own internet. I know that the first phase, the phase we're in now, is this commandeering dark fiber and stuff that's not being used. But at some point, I think California is going to have to break their own ground and start placing their own fiber. And distance is not an issue. So the motivation to worry about that is not there. But you do have a law saying you need to GIS your stuff. So again, even though currently the new stuff being placed isn't distance sensitive, with the law in place saying you have to do it, and a system that's already built to do it, it's not a big deal. You just have to physically GIS the spot as during install, which is not a complicated thing to do. If that helps.
Yes.
Okay.
Thank you.
Yeah.
Okay. Do I have more hands raised? Oh, I have more discussion.
Member Munoz, this is, or Chairman Munoz, my apologies. Again, Steve Cleaver with PG&E for the folks on the phone. Because Mr. Worcester brought up the conversation around accuracy and introducing essentially lat long and GPS into the discussion of GIS, I think it's important to have a discussion and hopefully generate some conversation with the folks in the room about the difference between the current requirement, which is to map things in a GIS system, which the GIS system itself is the spatially aware system, without a requirement for specific accuracy of locational information for the asset itself. That's fine. It's a company asset. I'll pay for that later, I'm sure. But the idea that, like, for example, right now, PG&E has gas assets both on the distribution and transmission side. We have electric assets on the distribution and transmission side. We also have fiber optic assets that we own and that we lease space on as well. And then we have power gen assets as well. All of these are mapped in a GIS database, but they are all mapped fundamentally differently in the GIS database because of their purpose and also because of how cluttered a map can become and become unusable for folks in the field. An example of that is even if you take the layers away and we're just talking about electric assets, the number of conductors and empty conduits and boxes and services that you can have, and then layer on top of that the overhead assets as well, and then color coding and visibility to make it usable for the field, and to try to get all of that on one side of the street and say this is where all of this is at with GPS accuracy down to the map essentially becomes unusable for folks in the field at times. So having some ability based off of utility, based off of the assets they own, to be able to make some decisions for themselves to say, this is what's usable for us, this is what will actually work for people in the field based off of current technology. I think that there has to be some sort of awareness that every utility is going to be a little bit different, and the capability, even if we have it, to map it to sub-centimeter GPS information, to visualize that on a map that makes it usable for folks in the field is extraordinarily difficult at times. And so I have a little bit of caution or trepidation around introducing GPS accuracy into regulation at this time, based off of the drastic differences in utility types. For example, the plumbing of gas and water lines and sewer lines versus the operating schematics of a telecom system or an electric system. They're very drastically different systems, and to apply the same requirements on each of those, I think it's going to require a lot of stakeholder engagement to make sure that we're doing it right.
Thank you. Okay, guys, here's the thing. We just had one opinion out here. I want to hear the other side. That's the operator. Do I have excavators out here? Who's using these maps that are being referenced with all these layers on it? It's so hard to read. Does anybody else feel like that it is impossible to use this tool? On the line, I have 80 participants. Does anybody want to speak to that? Because the comment was, it's impossible to read these maps. I want to hear more about that.
This is Don. All right. Royce Pedrosi, I'm in Contra Costa Water District. The first question of like when we would like this implemented, for me, I would like it implemented when we do like deliverables, when we get our as-built, when we do our consolidations of our real plans. But I worked in government for a while, so I don't trust as-built, especially when you have multiple generations working in a utility. A plant that you work in the 50s, the 70s, the 60s, all the way till now, you don't know what as-built you're actually going on. So now that I'm out in the field with the distribution teams in Contra Costa Water, excuse me, we basically, it's like the Wild West because you have PG&E, you have other municipalities in the same ground, in the same right-of-way, and we utilize our GIS basically when we go to respond to a hit main. We just come to a puddle of water. You don't know where it's going. We look up our basically our GIS, and you see that it's a 16-inch main, and then you look up and you see the service lines. You see that there might be something you call on a USA, and you essentially, excuse me, it's been a while since I stood in front of a podium. So we basically show up there, and our staff is to evaluate how to keep the services going, how to keep the utility going, how to keep the water under positive pressure. And so we look up our maplet and we see what we're going. We utilize it to see what systems we have connected to it, what the major players are, what the systems are going to be affected if we have to do a shutdown, if we can do a shutdown. And then we call on a USA, emergency USA, to see if we get the other utilities to basically react, respond, and get there within 24 hours to market so we can start excavating. We make our assumptions in our digs basically what we see on our GIS. So when we go into our GIS and we see like we have A, B, and C in here, and we open it up, we start doing soft excavation, and it's not in there, and we still have water running, then we start doing what we call chasing the leak. We have to make guesses on where the water's coming from, what conduit it could be coming from, other utilities that are going to be across it, and it puts our first responders in kind of the hot spot because they're out there, water's running. We don't want to shut it off without creating a huge water quality incident. And then we also want to do what we can to minimize impact and damage to the surrounding area. So for us, we would always like the best information like yesterday. So when they're designing the pipes, when they're putting the pipes, when they're doing the as-builts, we would like to be more involved in the design of like where it's going to go, because for engineering, it seems like, we all got limited assets, we all got limited resources, so we got limited budget on what we could do. And engineering and planning and design, they're just trying to get their job done with the limited assets and resources they have. And at the same time, we're trying to operate with what they can give us. So it seems like sometimes there's like a conflicting objective. They're trying to get them in as fast as they can, replace the stuff as fast as they can, to the most cost-effective they can. And sometimes GIS is involved in that. And other times it's just a check on the box, and we find out probably after the fact, hopefully not during an event, but we'll find out generally during an event. that we pretty much have some wrong data in the ground or in our GIS system. So we eventually will just try to map it, redline it. When we're doing it, we'll repair it. When we take notes on our side in our OMMS system, we'll basically go in and we will note what we do. I'll note the leaks for like my water quality reports to the state, but then there's like a disconnect of like us redlining that and getting that to our GIS team, which is essentially just one person. And then they have a backlog of all the ongoing projects, the O&M projects, and then our wants and our needs. So it just seems to be like it's always a conflict of limited resources. The last company I came with, GIS was a very like driven thing, but that came about by basically a lawsuit from a Sport Fishermen's Association. And so if it wasn't from that lawsuit having teeth, I don't think the company I was working for previously would have ever invented and gone into that to put the resources that they needed in place. Once they did, and we started layering the GIS along with our MMS and our CMMS systems, then it became really great. But it was also a significant impact to our operation to put all the resources to that to get it to that point. So where I'm at now in CCWD, it's just a challenge to get our contractors to bid on certain things and then do certain deliverables, and at the same time to get the as-built that we actually need, and then to actually have that be a layer that we deliver. Like, you will not get the final check until we get this. That seems to be a pretty far-fetched thing right now.
So today it's your world, and I'm sure you've had these discussions where you say, they should do this, they should do that. So you mentioned a couple of things that I thought were really, they speak to the heart of what we're trying to solve here. You mentioned that in the event of an emergency, you kind of started to mention about maybe precision and accuracy, maybe. I want to know a little bit more about that. It sounds like in this scenario you already have damage. So recovery, damage recovery. How precise or how accurate, what would be the if you could tell them, how accurate and precise would you have these GIS, the Latin longs or the as-built? What would be your ideal? What would be your coworkers' ideal? What are you looking at?
Well, I mean, for myself and a few coworkers, it would just be nice if we kind of had the same scrutiny of everything that we had, like on like say a petroleum pipeline that was running along a public DOT right away, where you have to know where it is, what side of the rail it's on, where it's going, the plan and leak response. You have to have constant monitoring. But I know that on our side, that means our ratepayers would probably be paying, triple what they're doing right now, and we would have to have some conversations with that. From the O&M side, it would just be nice if we were going to go, and let's just say not in a response world, a planning world, where we had our construction staff going to install a certain pipeline and everything, or they were just going to modify an area and they were going to set stuff down. There were basically many times where staff will go in and say, we're supposed to install this 6-inch, we're supposed to go this, we're supposed to put a fire riser and fire service over here, but now there's a pipeline. We don't know who it belongs to, we don't know what it is, who it goes to. PG&E says no for electric, gas, and then the telecoms say no. No one knows what it is, no one wants to claim it. That's a fun one. So then we have to go and make modifications through our side to either do a lowering, a raising, or modify our plans completely to do that. And then, of course, when it goes into GIS, a lot of our staff will be like, well, why are we doing that? We won't really put a note in there like, hey, this is what we're doing, but it becomes a lot of reaction to a lot of things that you can't really answer. So for me, it would be nice if it was actually down and you had all the lines that were actually in there and someone could actually claim them, and if they can't claim them, then they get marked by somebody.
Okay. Thank you so much.
No problem.
All right.
Any questions?
You covered almost every single topic in one comment, so you did amazing. I'm just going to ask you, if this is all about safety, and it is, what can we do to make this entire GIS, our subsurface installations, how can we make excavations safer? Today's your day. You get to tell the they what to do.
Well, today it's just, for me, it would just be nice if we knew if they knew what we need on the end to be, like, to have all the tools in our toolboxes. If I could have connectivity to have my staff be able to flip open a laptop, get accurate data, get accurate layers, and then maybe have some sharing layers between the other municipalities of what to do, that would be great. but there's a lot of companies that aren't too forthcoming with opening up certain information for, you know, obvious reasons. But it would be nice if there was a little bit more collaborative or maybe more regional efforts, kind of like what the North 811 does, but like between the smaller areas. Like I work in Contra Costa, so it'd be nice if like the local little cities that are around there could actually work a little bit better amongst themselves to say, this is our data, this is where our DOT lines are, this is where our data lines are, this is where we have our right-of-ways and everything. But it seems like everyone has various layers, and they're all kind of a little abstract. So when we have to react to that, it becomes a little bit more challenging. So it'd be nice if there was a little bit more open collaboration and a little bit more openness to certain things and a little bit more, I mean, just onus to just accept certain abandoned things without worrying about what is this going to do to my utility down the line if I accept this abandoned whatever. Everyone seems to look at it like a liability point.
All right, thank you. All right, so we were on asset management. It seemed like we stopped answering that question. Does anyone else want to talk about the asset management portion of it? And I guess there's been a lot of mention of like there's two separate systems. I want to know if I have the 86 participants, this is fantastic, how you guys harmonize the asset management portion with the GIS portion, because our last speaker just described a whole situation where they're redlining drawings, they found assets, there's things where they shouldn't be, or maybe they're surprised, they're here. Can someone speak to that? How are they updating when there's a new installation or they find something in the system? How are you harmonizing your different systems? Is Dave Woolley and two others, is that new? You want to call on them?
Yes, we do have raised hands. The person in line was Michael Worcester.
Okay.
Thank you. I kind of want to, again, remind everybody I'm not representing directly any particular utility. I can wear the hat of a utility or an excavator or locator because when I was with them, that company was also at the time the biggest excavator in the state. So we always try to find a balance. But I want to kind of lead off of where Steve left about the having a map that was extremely complicated and unusable. And if I took all of the information in a given aerial view of one of our maps and shoved it on there at once, it would also be unreadable, but we have layers. We separate out layers. And since we're talking in the context of purely damage prevention here at the dig board, right? The way we did it, we would hand certain layers to our contract locators and certain layers to our contract excavators. And those layers are coming again right off of ArcGIS, and they can or cannot be, they may or may not be lat long accurate. But we redacted enough of that information to make it very usable. We just simply call them conduit prints or an aerial print, showing basic placement of poles, the riser poles to the manholes, their basic placement of conduit duct banks and buried trenches and such, or direct buried and joint trenches. And again, not accurately lat long accurate, but it has the ability already built in because it's ArcGIS. So if those things were corrected, it would be all accurate. So you brought up the question of, well, how accurate can we do it? I think that question really comes down to 4216 right now is showing a 2-foot buffer zone, and it makes things extremely difficult for a lot of excavators. A lot of excavators I've helped, a lot of excavations that have hit me as they try to pothole to find these things. The pothole can become very giant, very expensive, and many of them give up and assume either I'm not there or I'm deeper than they're going, or not as deep as they're going, those kind of things, which we know those all lead to damages. So with modern technology, with our handheld GIS devices, and even with the brand new iPhone, which is probably the most accurate one, both the iPhones are down to a few feet in many cases, but the handheld's down to inches. And I think there is an opportunity to make things, the damage prevention world, work a lot smoother for locators, for excavators, for designers, if we utilize that technology and we get down to the inch. I don't want to frame it in a 2-foot tolerance zone, but that's just there because electromagnetic locating devices are inaccurate. That's why there's a 2-foot buffer zone. But I think if we're talking about a modern GIS device that's affordable, which they have gotten a lot better and a lot cheaper, really from the world of drones and such, all this technology is filtered down to devices that are reasonably priced for just about anybody to get down to the inch or two. And it's a matter of just standing above a utility and clicking it. It's not a complicated thing. And all the modern locate equipment come with a GIS. Many of them, the best ones, the most common ones, as they mark, they can GIS as we go. Doesn't mean that's 100% accurate, but it's a start. It just means there's a lot of technology out there to help us get down to the inch already here. There's no reason why it shouldn't be the inch. And I know that's basically why we talk and how are we going to build the law? How should we state it? And I think that within the inch is a reasonable, within a few inches is reasonable. A, because we can, and B, because it really benefits the excavators and the utilities, because downtime's going to go definitely much lower, as they're not going to be doing these 6 foot, 7 foot sweeps with a hydrovac looking for something. And damages consequently will go down. Utility installation will get cheaper for the utilities, and repairs will get quicker and easier. So I think it's a win-win for everybody if we focus on getting as accurate as we can down the inch, because the technology is simply there. So that's what I wanted to fill in for what we just talked about. So
Thank you.
yeah.
Okay, we do have another raised hand from David Woolley.
Go ahead. Mr. Woolley, go ahead.
Good morning. I think we're confusing a couple of things here. What we're dealing with is GIS is essentially a file cabinet where you archive data. The quality of the data varies because it's the file, it's the holding place. When we look at 4216.3 GIS, that's again, it's just a file cabinet. Now, if we're talking about designed and permitted structures, underground utilities, they're generally designed within, let's just say an inch. That's the design. And they're built within the contractor's ability to put those in. When they build them, they're generally very close to the design, which is again within an inch. And then the process is when they're designed and then there's a field modification, then it becomes a red line, which a lot of times won't make it into the digital plan set. And so when you're talking about new facilities, they're going to be designed and built within inches. The file cabinet that you put it in varies, the background varies. And so new structures are designed very, very close, and they're oftentimes, most of the often, required to be as-built as they're built. It's the process of what do you do with the as-built and what's the as-built process. That's usually going to be done by the contractor, which is only a variation from the design. So if you required, just for instance, that all new construction plans with underground utilities were to be placed on the California coordinate system, which is very, very common. Almost everybody's using that system. Then it's just a matter of which generation of that system you're using. But GIS does not create this. GIS only archives it, and it's only the quality that you put in. I think that's an important understanding. And so when we're looking at this, when they talk about inaccuracies, those are inaccuracies that are legacy systems that were put in place for different reasons. They're existing facilities. This particular section of law is pertaining to new infrastructure, new installations. And so the process is outlined in almost every agency now. It's just a matter of getting that design in place. The design, and the last thing I'll leave on this is, if you're dealing with gravity lines like sewer, storm drain, those are generally going to be within less than an inch, depending on the diameter. Water line vertically is less accurate because it's under pressure, and so it has a minimum surface coverage. So if you're talking about implementing something at this point, you would want to put the design on a common reference frame. and that would be the end of it. It's the design. That would go into a GIS, which could have all kinds of varying qualities, but it actually is going to be very well, very accurately placed in there. And what you would want to do is capture the red lines, which they call them red lines because they're done in the field, on the job, and kept in a trailer, and they don't always get back into the digital version. Well, that's what I'd say is when you're saying GIS, you're talking about the file cabinet. When you're talking about new installations, that design is very precise. Now, if they run into something in the field, like an existing structure, infrastructure, abandoned, then that's usually field located because they may have to modify the design, which becomes a red line. And that clarification is important. So you want to get the design on a common reference frame, California coordinate system, common vertical reference frame, NAVD 88, and then it gets archived. That data is very accurate. Now the GIS file cabinet data, all the information in there may be inaccurate, but if you date and timestamp it, you have an accurate model. Thank you.
Thank you. Do I have other raised hands?
We have a raised hand from Jamie Reyes.
Oh, go ahead.
Hello, Jaime Reyes, SoCal Gas. Just to go back to the question of how do our as-builts get into GIS, we do have a workflow that involves reviewing the as-builts prior to approval. That involves checking for what we call like GIS mapping requirements, excuse me, such as reviewing the land base, making sure the assets have dimensions to like a fixed land base reference, like a right-of-way, property line, parcels, that kind of thing, in addition to some other checks that we do. But essentially, that review process that's done before the as-built is approved is to ensure that we can map it sufficiently in GIS. Additionally, being that we have high pressure gas pipelines and medium pressure gas pipelines, we do have a practice on the high pressure side for construction to also do as-builting with a GPS survey. So we have data points for GPS for our high pressure system. That's not a practice for the medium pressure side of our system. There's a long-term plan to address that with GPS, but just to give context to how does as-built get into GIS, we have an established workflow. The designs do not make their way into GIS. It's the actual as-built that gets posted in GIS. But we do have something that we call during the design phase or pending construction phase, and when it's pending mapping in GIS, we do represent the area of work in our GIS system with like a work in progress polygon that represents the work area to notify key staff in our operations about in progress construction or pending mapping to alert them to that. And we do provide a link to the design or preliminary as-built so they can refer to that. So just speaking a little bit about our workflow for as-builting into GIS. Thank you.
Thank you so much. I have a couple questions for you since you were speaking about your as-builts migrated into the GIS system, and you were talking about checking for the coordinate. I guess you're taking the as-builts and you're mapping them into your GIS system. Can you tell me a little bit about your, I guess, the established standard for precision accuracy? Do you, the last couple speakers were talking about inches. Is that something that is identified in your process?
Well, for the high pressure aspect, in terms of like the design is tied into land-based references. We have dimensions to that. So there are control point surveys, like GPS surveys that we do for high pressure. So I'm just kind of speaking at a high level in the realm of the high pressure assets that we have. I mean, that survey, the GPS survey is accurate. So when we get those data points, very accurate. When we get those data points and we use them as reference for mapping on our high pressure gas lines, our practice is there's a little variability. If you imagine like breadcrumbs being dropped for the GPS survey, they're not going to perfectly align, even though it's a straight asset, a linear asset. There's going to be a little variability between that. But so our mapping practice for high pressure is to place the line, the linear asset within 5 feet. As long as we're threading the breadcrumbs through the GPS points that we're collecting on the high pressure side, we have, you can say, within 5 feet accuracy of the GPS survey, because there's a little variability that we get with the data points. So it's pretty accurate on the high pressure side. On the medium pressure side, it's different. We're using the term we like to use is relative mapping relative to the land base. So it's the accuracy of our medium pressure assets is only as accurate as the land-based data that we work off of to, like, for example, this pipeline's 20 feet from this property line, right? So there is variability in that land base. It's hard to quantify what that is. We use a third party to acquire that data, like, property parcels, et cetera, road center lines. So, but it's hard to kind of give a number for that. But just to give some context, the high pressure side's really accurate, fairly accurate for new construction GPS survey. And our practice for mapping is get it within 5 feet of that data point.
Okay, thank you. Okay, so I have some more questions based on that one. When I first started on this just for entertainment purposes, there was a Mylar that we were trying to GIS, and it said the great oak tree, 20 feet off of it. There was no more great oak tree, right? So land references are difficult and challenging. So for my 87 participants on the call and all of you here, can you tell me how you use monuments, maybe land references? How do you establish? Oh, you're still there. How do you establish location for your GIS? What's your reference point? Can you tell me a little bit about that and tell me what your standards are for that? Because I just remembered that oak tree and how annoying it was when it was gone, and that was my 20 feet off the oak tree. Anyone want to speak to that? I see lots of eyes. Come on up. Or raise your hand. Oh, do I have new raised hands? Are those new? Okay, David Miller. Go ahead, David Miller.
Yeah, this is Dave Miller from the city of Merritt Canyon. We usually use the benchmarks that are out there, but recently we've been just borrowing Caltrans monuments for our benchmarks, both horizontal and vertical. And it gets you within sub foot. So for us, that's pretty much good enough.
Are there any excavators in the room? Anyone? Come on up. Tell me how you guys do it in the field. I want to know more about this. Do you use monuments? Do you use the great oak tree? Do you use Caltrans markers? What do you use?
Is it working now?
Yes.
Okay, good. I work for the city of West Sac, and I happen to be a guy in the field. So let me just give you my background. My background is surveying. So, and actually I was employed to come and do survey for the city. And the reason I was employed basically was when the city was incorporated, there was so many infrastructures, there was no quantification about it. Everything was in disarray. So anyway, the first thing we did was to establish monuments. So we have a record of survey which includes probably 111 monuments, which includes Caltrans. We have this Caltrans monument. We have USGS monument. We have so many. I can't remember some other names anyway. So what the city did was that to establish those monuments in grids. And we have all those monuments in local coordinates and in latitude as well. So which means if you measure, if you put an instrument on a particular monument and check on the other monuments, it's going to give you exactly, if it's 100 feet, you're going to expect to get 100 feet. And that's how we've been mapping all our utilities. And I can guarantee you our utilities in the city of West Sacramento is 99.9% accurate.
Awesome.
Because we have the city monuments, we have the USGS, and anytime you put an instrument or either a total station on the GPS or even tape measurement, you're going to get the same accuracy every time. Because we have 111 monuments that controls the whole city grid. And I can tell you it's 99% accurate. So, I mean, the whole idea of this seminar is accuracy. And the reason is that, I mean, we've had events, especially 2-3 months ago, we had a false main that was broken, I mean, twice. And it took us probably 4, 5, 6 hours to try and even get it recovered. And the reason was that probably years ago, the pipe was there and nobody knew the pipe was there. And that was what's broken. But right now, we've gone to a point whereby we are checking. Okay, right now we are going back to check everything that has been there before the city was incorporated to make sure we surveyed it and precision accuracy of within 5 millimeters. I can guarantee you that, and that's exactly what we've been doing. We've been mapping right now. So I think that's the whole key is to get the proper monumentation. That's all.
So today it's your world.
Yes.
And it sounds like you have a really great process.
I'm telling you it is.
So if you were to prescribe everyone your process, and you get to influence us today, right, with your opinions, tell me what steps would you make universal for everyone so that we can have accuracy?
Okay, the first step is like one of the speakers said was that we have what we call the design stage. Design stage is quite, anybody can do any design. Say, look, I want a pipe here, I want this is here. That's normal. Now, we have the construction stage. The guys in the field, I'm telling you, I work in the field as well. 99% of the time, it's not going to be accurate. What they do is they probably put a manhole here. If the design says it's 100 feet in between 2 manholes, I can guarantee in construction it's going to be 102 or 90 or less than that. That's fine, and that's due to so many reasons. Now, it's the job of an inspector in the field to figure out there's a problem with the construction, and that's why the red line comes in. So the inspectors get a plan and say, look, this is this, and I'm redlining this because it's not accurate in the design. And that's the job of an inspector. Now, the inspector's job now is to translate what he has done either to the engineer or give it to a surveyor to accurately GPS the changes. And when that is done, and if that is done, and that should be done anyway, and that's the process of what we call the exact record map. Because all we get, I mean, we've had so many subcontractors in city contractors. They give us record maps and all that. I mean, we go out there, we find out it's 5 feet difference. It's 5 feet off, 10 feet off. So I think the best thing to do is, I think the best policy is to make sure before they deliver any deliverable, they should be surveyed accurately. And when it's being surveyed in conjunction to some particular monuments. That should be probably monument 100 feet away, which is either USGS monument or city monument, and that's the only way you can get accuracy. I think that's what I think. Yeah.
Thank you.
I thank you. Did I answer the question or one
more? You
more?
absolutely answered the question. Thank you. All right, so we've covered asset management. It looks like we have gone in and out of talking about GIS data and maps to prevent damage. We've talked about events that have occurred, and I keep seeing everyone look happy, but come on up and talk about it. These are the questions that are in the section number 4, GIS for damage prevention. So here's some of the questions. How is your organization using GIS data and maps to prevent damage to underground utility assets? And if there's situations where we couldn't prevent damage for whatever unknown reason, please share that, maybe lessons learned, something that you think everyone, today is the day. You know how you go home and you say, if only they would make them do X, Y, and Z, the world would be better. Today you get to say that. We're listening. Does your organization provide GIS-generated maps to all of the stakeholders? So those are the questions in that section. And then I'd like to close that section up and talk about the real meat and potatoes, which is the accuracy and precision. So does anyone want to talk about maybe a situation that occurred? I'm not sure. The other question that I would have is latency. What is the time period between putting an asset in the ground and when it gets mapped? And does that have an impact in your mind, in your world, when you create the perfect world? Does that have an impact on damage prevention? Come on up. I see you shaking your head. Come on, everyone.
excuse me, but Chair Munoz, we do have a couple written comments as well as a couple raised hands. I don't know when you would like for those to be read out.
Okay. We'll take this one and then we'll take a break after that.
Okay.
Thank you.
Hello. I'm Nathan Jennings. I work for the City of Sacramento. I have a few of my colleagues here. We work specifically for our utilities department of the city. So we have underground water, wastewater, and storm drain. So we're effectively the utility company of the city, most of the city, for some of those services. And I would agree with lots of the comments that have been made already and have the same challenges. I think I'm just going to go through some topics here, but
bring it.
Yeah. So I'd say we the GIS people provide information out to contractors and our engineers for designing and bidding projects and things like that. I'd say our data that we provide out is not like the survey accuracy to work on, and we do state those things like don't don't map your stuff against ours unless you go out and verify it and things like that. So we try to get that out there. We typically will receive digital files in the sense of CAD drawings are sometimes provided. Also, PDF of those CAD drawings are provided. So even though there's a digital submission, it's not necessarily CAD that we can directly import or use into our GIS. So that's something that we have to deal with. And I guess in an ideal world, we want that data in ready form for us to use instead of like georeference plans in and stuff like that. So those kind of things. As far as like accuracy goes, we do have a standard of the NAT 83, NAVD 88, but how we get that information, maybe in an older standard, maybe in some variation of that. I think the enforcement of that standard is difficult for us, the city, to make sure that that's happening and hold those contractors, whoever's submitting that, accountable. So that plays into what we need to do in order to get the data into our GIS. When the areas are under construction, I would say our GIS group don't get those plans or information until after or the project's in closeout stage. And so we may or may not receive information during the construction or the in-progress kind of phase of things. So we're looking at inputting that information into our GIS after the fact. And then there's this kind of like warranty period that, we want to make sure that whatever is in the ground is accurate and all that kind of thing. And so we're usually up against a wall to have that information in the GIS so our own inspectors can go out and inspect it and make sure that's actually what's out there. There's challenges there. I don't think we're using or contractors are using high-end GPS while the information's or the infrastructure is being put in. But, we are, I guess, occasionally going out there and using GPS for some of our validation, things like that, especially older information. So, and depending on the size of the project, there could be a lot of data to be put in. Not just if we have a CAD file, we're just not putting it in. We're using that as reference, and so it can take a lot of time. And on a much larger project, we may be up against that deadline on the warranty period, or if we would be able to get that information sooner, we're running up against we're putting the information in for reference and helping the project move along, but it could be incorrect. So we have to balance the accuracy of the information that's out there while in construction versus what actually is or has been constructed. So aside from the warranty period, we're also looking at maintenance schedules being produced off of that new infrastructure, and then also if there's problems with that new infrastructure, how do we respond to that? So if there's no GIS layers or map layers in our work order management system, then the field staff can't go out and find it. So there's that kind of challenge. Also, I guess during the construction in some of these larger projects, there may be cases where, the roads aren't completely built, but there may need to be public safety going out there for, theft and vandalism and things like that. Or there could be problems that are happening while the construction is going on, and so they're, not having that reference information is difficult. So we tend to have the GIS team usually gets that information after the fact, as opposed to during or in design, that kind of thing. I'd say for accuracy, yeah, that's a big thing for us, and I think trying to match the newer information to our existing infrastructure is difficult. Certainly if it ties in, ours can be very way off of what's out, what's currently designed. So those are challenges that are ongoing. And I think also to the comments about how much information is out there so that field staff, responders, whatnot, can go find things. The maps do get really busy, and finding ways to, in GIS kind of ways, make it usable in kind of a dynamic, web environment. A lot of times the field staff are also asking for, plans and things like that, just so they have that at their ready. So it's a little bit easier to kind of look at a page versus, scan around a little screen on your laptop. Those kind of things. We do have USA crews that go out and will mark stuff for us, and so they will have references off of center lines or curb corners and things like that. So those usually come back as walk-off measurements that we end up putting into the GIS layers in some cases. And then in an ideal world, I think we'd want to have the 3D representation of all that. I don't think, at least for our case, our data is not like ready to do that at the moment, but the rim elevations and depth and stuff like that is becoming more important over time.
Awesome. So I do have two questions, and then I'm getting a suggestion to take a little 10-minute break here. So it sounds like you're describing there's a latency between when the project is in its closeout phase and when the data gets in the system. Mm-hmm. Do you see that lag time between having the asset data available in a GIS system? Do you see that as a risk for safety?
Yeah, I'd say certainly for like the water side. If there's problems between what's in the ground and what's constructed, well, I think we've recently had a almost potential situation like that where like a subdivision's getting built out, the infrastructure's in, people are starting to move into homes, and just making sure like their water system, like when they turn the water on, it's clean, things like that. So I guess if that's there's a risk there. And if there's something that wasn't done during the construction or the inspection, then I'd say there's some risk there. And, because it's newer infrastructure, the fact that we may not have that in the GIS, but someone needs to go respond to that, then I'd say, yeah, that's a risk to health and human safety.
Thank you. Okay, so with that, we're going to take a small break. We'll come back to how many did you say new? 2 people? Okay, we're going to take a 5-minute break. 5-minute break, and there are 2 people on. That'll be the first one in line, and you guys can all develop your comments because I expect everyone to come up and speak today. I'll see you in 5 minutes. All right, so we are back from our little break.
This conference is being recorded. Only the main conference is recorded.
Please forget the part. Okay, so we're back from our little break, and one of the last questions, the groups of questions that I was asking was about the accuracy. No. It was about damage prevention, and it was the latency between the design and the GIS into the system, and just the overall how does this affect safety? And I had someone in the room that wanted to go ahead and speak. So go ahead, Sierra.
It's me again. I wanted to put forth one thing about safety involved in the latency between things being designed, installed, and added to GIS, which is talking about fire hydrants and how important it is for in our process that those be mapped immediately and accurately and put into the system used by emergency services to respond to a fire event, which also, you know, things happen on construction sites. So fire hydrants are usually one of the first things that go in, and they need to be usable and usable quickly for emergency services. So in terms of safety, I think that is a big one. That's all.
All right, so now we'll go to our two people on the call. Thank you so much. It's Michael Worster, and I see one other hand raised. So Michael Worster, would you like to proceed, please?
Sure. Yeah. Of course, I have other things to say about what was already said, and I know you have very specific questions, but I think a good purpose of this meeting is to uncover any other questions. So I just want to talk about some of the things were said. Accuracy, we all know, I think there's agreement here that the system can be very accurate. And as far as map congestion, I think that's easily dealt with. And I think what David Woolley brought up some good information, some good points about process, you know, and an idea of installation and post-inspection and all that. And you did ask about an example of a situation where you solved an issue. And I did have a situation a long time ago where we had to have a fiber company came to pull fiber and run it next to ours. Ours is a pretty new fiber, and we overbuilt it. And because of that, the federal government says we have to lease out stuff. So they were co-locating with us, and then it would be next to us, and he'd be co-locating with us, along with maybe 4 other companies. And this is all related to the infrastructure bill, really. It's about getting fibers just being placed at extremely fast paces. And they hit us. They hit our cable several times, our fiber cable, even though we had given them prints, we had given them everything, all the information they needed, we believed, because the stuff we had installed was brand new as well. And after uncovering the earth physically and seeing what happened and seeing how many times they hit us, we noticed how many times our cable crisscrossed out of what we were told it was placed, where we were told, along with several other companies that were brand new were placed in a weird spot, and it cascades from one issue to another. So I think in this case, it was an old water valve that was in a place we didn't expect it. And the first company dove around it to the side, and then the next company dove under that one, and next you know, it's just crisscrossed everywhere. And people are signing off on saying this is accurate. We placed it the way we were told to build it. Because if they have to come back and say, I have to move it, then it's a redesign, and that's expensive, especially when we're talking about out-of-state contractors, because these things go to open bid national. California contractors can be a lot more expensive than outside contractors from different states. And they're very common, they're subcontractors especially. Even design companies from out of state. So what we found was that our inspectors, who I brought, my own internal inspectors and engineers that I brought to the site to try to figure out what was happening, were responsible for post-inspection of the installations. And they never did it. And that's just kind of what we see. We see and we asked them why, and it was more about workload. And that's just the reality of what's happening. At the pace of new installs, and PG&E's can be right behind it with their underground, the pace of installs are so fast, and there's so many cooks in the same kitchen. The reality is no one is accountable for their post-inspections to say, yeah, it's new install and it's really here. And there's a lot of reasons why. And we can't control the reasons why, but it is an opportunity maybe to legislate the process and accountability. Because right now there's nothing. We say, yes, here's plans that we believe are accurate, go build it. And if you have any changes, come back to us. And when you're done, we'll come and inspect it and verify the placement. There's a break on that line because the reality is there's no accountability. And accountability within the company is one thing, but accountability from the dig board is another. I guess that's maybe something we should look at as a group. Do we have accountability for saying, yes, we accurately GPS'd it, and that's GIS, but GPS the location after the install. And I can speak on latency for that. When that is signed off from our inspectors, it instantly goes into the maps, and those maps are instantly updated to our cable locate contractors. So again, issues inaccuracies are cascaded quickly down all the way to the field, but so would be accuracies. So my real world experience is telling me when we look at the congestion of any busy right-of-way area, anything urban, that the accuracy of even new stuff is not there. It's just not there. Because there's no accountability to who's actually doing it. They can sign off on whatever they need to sign off on. A lot of engineers that just aren't going over there and checking on the contractors. They assume it's okay. Or they just know this is not how it works and they're not involved in the damage prevention world and they don't understand the other problems that it causes later. So that's what I wanted to add in.
Thank you so much.
You're welcome.
And I have the next person who was next in line.
Yeah, hello everybody. My name is Brian Coward. I'm with the city of West Sac too. I think we're over-representing ourselves here a little bit, but I wanted to thank Rotimi and Sierra for showing up in person. And thank you guys for organizing this event. It's good to hear from everybody and their how they're working, what their systems are. I just wanted to add that we had talked about kind of the safety aspects and latency. And Sierra, yeah, you hit the nail on the head with the hydrants. I was gonna bring that up as well, but we also, part of our process is to utilize whatever control points we can locate on the surface in order to map our subsurface utilities. So when we go out there, when Rotimi goes out there and collects the hydrant points, we use those points to geo-reference or map our subsurface utilities, the water lines, and so just in general with our systems are water, sewer, and storm. We do streetlights too, but that's not really relevant here. And I think that a lot of this process improvement in terms of making sure these red lines make it into the CAD deliverables that are provided. There needs to be, I would hope, some requirement or regulation that would really help, I think, in that regard, to make sure that that the mapping services that are provided through municipalities are a part of the process and is part of a requirement. That we're able to check these deliverables and work with the inspectors to make sure that all the red lines are getting into the CAD files and being able to utilize those CAD files for GIS deliverables rather than having to remap everything. The design's already done. That's 90% of the workload. What we really need is to have the ability to just import this information into our systems and trust that it's good. And whether that be we have a surveyor or hire someone who can spot check those deliverables in the field and make sure that to a certain degree, a percentage, everything's accurate and you can trust what is being provided.
All right, thank you. And thank you all West Sac, for being in attendance. Who's the next commenter? Because I see another hand up. So, go ahead. You can come get in line. We have.
Yes, we have David Woolley on the line.
Okay, go ahead, David Woolley.
Thank you. Okay, I think the best way to capture the most data accurately or not the best, but one way is during the permitting process, because during plan review, I review plans at 30, 60, 90, and 100%. So before it's permitted. So when we're doing 100% review, that data is accurate for major infrastructure, storm, sewer, water, similar things like this. Is very accurate and it's complete. And the only thing that's missing at that point is the field design red lines. And those may or may not be captured digitally later, usually not. They're usually in a trailer. So if you make it part of the permitting process, you will capture most of the data in an accurate format. It's generally in CAD. There will be some concerns about releases of liability because in the construction world, the signed, approved, hard copy plans are the final. The CAD drawings are not, and I'm involved in some of the liability actions involving that. But if you make it part of the permitting process, that's good. Now, what you're not going to capture in permitting is micro trenching. Some of the work that we see, like fiber optics, a lot of times that work is not designed, permitted in a way, the way major infrastructure is. It's kind of horizontal directional drilling. Those kind of projects have an inherent inaccuracy because of the way they're permitted and the way they're put down. But all your major infrastructure at permit time will be accurate, very accurate. The missing component on that is whether or not it's tied to the California coordinate system, like a NAT 83. And so if you created a permit and then you created a requirement that it's tied to NAT 83 or to a reference frame that's common, which is California coordinate system or the North American vertical datum of 88. And I submitted a report kind of detailing some of those things, and I won't go into all the wonky details here, but capture it at permit at 100% as part of a submittal package and permit process, you will capture 99% of that data accurately. And again, the GIS may be inaccurate within itself. The existing may be inaccurate, but going forward, everything would be accurate. Last case test on this is we did this back in the early 90s for the parcel level for the County of Orange. And the County of Orange GIS system is sub-foot for almost every parcel for almost every area except for some of the foothills. And it was done by ordinance. So anyway, thank you.
Thank you. Okay, you're up in person.
Good morning. My name is Luisa Maria Gomez. I'm the Information Management Manager for the Sacramento Area Sewer District, the collection system operations side. Regarding how we capture the asset information, we start always at design. Plans are submitted to my group, and there is a status where we say in design, and the time is usually 2 weeks where we are able to we have different priorities, and please don't quote me on that, although I look at them a few days back. It's between 2 and 6 weeks where if there is a change in the design, then they submit a new survey request through Maximo saying, please update this information in the assets. And people can see it in the field. Our operation and maintenance folks see that they are actually in design. So nothing that they have to respond to, but they are aware there are facilities coming there. Then it changes to construction, so we reflect that as well. And that's a priority too, meaning within 2 weeks we need to reflect those changes. And then if they are in operation and eventually decommission, retirement, if that's the case. And I'm talking in general for our assets, which are the gravity or force mains. For force mains, we actually have 3 different types of locators stated in our standards and specifications. Mostly we use marker bolts, so we get GPS coordinates out of that, and that's what we do. So it's a continuous feedback, and as well, because we have a lot of information, our system was built in the 60s to the 50s, so field staff goes in and find they're doing a work order for an asset, and they realize, no, the manhole is not in this parcel, but in this parcel, then they have the ability to check a box, and unless our survey request is sent to my group, and we can update that data. So gravity is represented graphically for what you address. That is difficult to see in a map, everything to scale, but we capture the information and that's how we do it. Any questions?
I do have a question because that's a really important part. It is very difficult to see a lot of things at once, but do you think training so you can take layers off and kind of visualize what you're looking for, how do you guys handle that so the map is readable?
So far, we have many layers so they can turn on and off. So to facilitate exactly that, if you're responding to a spill, well, they want to see drainage. While our crews are repairing a pipe, they are not necessarily interested in that information. So they have the ability to do that. But still, they have found it useful. They are able to locate the assets as they need. And what we are trying to do is also when a force main, which it doesn't happen often, thank God, because it has to be repaired because somebody just hit it. Then we go actively, somebody reports it to my group, and we immediately go and send stuff out. Or when it's ready, construction is underway, and we go and capture GPS coordinates of that. So we're trying as much as we can to capture that information.
Thank you so much.
Hello, Shauna O'Neill with SMUD. I'm a locator at SMUD, have been for 19 years. Speaking to the safety damage prevention aspect of it, and that's what we deal with every day. Speaking with PG&E and whatnot, I think the concern is the new law requiring GIS is great, but we have assets in the ground that have been there since 1960. So as a locator, I am looking at the map as a reference point only. I am going there to respond to the 811 and locate the exact location of the line. So I think a concern about the GIS requirements at this point is it's great for current that is going in. If in 40 years, if there is a different system other than GIS, then the law would have to change again, correct? It would be something that you're not going, say GIS goes away and it's something else altogether. So I think our concern as far as SMUD and the locators are concerned, we use it basically as a reference point only. I know the GIS people are saying that their information we put in is accurate, but until it is found in the ground and until we locate it, it's not accurate in our mind. So that I guess that is when we're talking about it and how the latency period for us as a locator, we expect as soon as that line goes hot, within 24 hours, it's on the map for us to find. But again, we don't, the way that we use GIS as far as the locators are concerned, we don't see measurements as far as, say, back of curb, back of walk, back of asphalt. We don't have any of that. We just show the line that is on the map, and we go to locate it. There are instances, obviously, when mapping is not completely accurate. Like you said about the tree, right? Well, we do have some areas where there clearly was a tree or something large at the time, and the line is making a little curve around. And you have to consider as a locator, is that an error on the designers or the GIS mappers part? Is that because there was something there? And so it's not the end-all be-all for us as far as how we are trying to do our damage prevention. So it's on top of it, on top of the mapping, we'll run into instances in which other utilities are causing bleed over onto our line. So as far as accuracy of the line itself, we have to take into account that there could be other utilities where it is bleeding off, and we have to locate and consider that when we locate. And really, there comes a time where the contractors are the ones that will have to, when they are potholing it to find those lines, are the times where the only times that we'll know whether our mapping or our locates were accurate, and that is affected by other utilities that are in the ground. So in a perfect world, I don't know how specific a GIS requirement could get, I guess, is my question.
All right, awesome. So that's a great segue because we only have 20 minutes, so this is the rapid fire time, guys. We're going to move on to section 1, which was the original. So now that we've had this whole discussion about monuments, latency, we've talked about the fact that the old stuff is not very accurate. I think the locators were saying, hey, it's a suggestion, we're going to find it no matter what it takes. Now the question, and she laid it out perfectly. Thank you, Sean O'Neill, for laying it out perfectly. In the dream ideal world, how accurate, how precise are we looking at? And this is with the framework of safety and everything that you described previously, asset management, everything else. And I'm going to try my best to give you a look like this. That means, okay, we got to move on because we want to get everybody. I still have 76 people on the call. So if you guys could line up with your comments, please, so I can get an idea of how quick we're going to do this in the rapid fire. Okay, go ahead.
I've seen that look before. I'm familiar with it. Again, it's Steve Kleber with PG&E. And just for reference, jack of all trades, master of none. This is one of those things that I know a little bit about, but not a lot about. But what Michael was talking about earlier, when he was talking about accuracy, he was actually talking about quality of records. And it was conflated with accuracy because, yes, the accuracy of your records is going to be impacted by the quality, but there is nothing that, no matter how quality the data is, or how accurate the data is, if the quality review is not there, the accuracy of the data doesn't matter. So it's the quality record and the quality management of the installs with the records that accompany that are really important. I want to be clear about what I was saying earlier, was not saying that it's impossible to read the map because there's so much on it, but saying that it becomes less and less purposeful to have super accurate data on a map where everything gets cluttered and it ends up being layered on top of each other. We absolutely use layers for all of our different systems, but and even historic stuff is drafted in GIS and visible to locators in GIS to be able to use it. They're even able to access records such as as-built through the GIS system to be able to reference those things to locate. But one of the biggest things that we have missed today is talking about the role of the locator in this. The locator is the one that is the primary user of these GIS assets in the damage prevention process that the Underground Safety Board has the greatest level of influence over. And the training of using those records and seeing those records and understanding what those mean, and knowing that there are historic issues with the way that certain things were installed. For example, historically something was mapped as having primary on the off-street side and secondary in the street side in one area or by one utility, and another utility operator for the same commodity, another electric company, may map it opposite or map it completely differently. So every utility company has legacy issues in the ways that they chose to do things that, regardless of how accurate their GIS is in the future, are going to continue to be things that we have to work through. And the ultimate constant in this scenario is the locator that receives these records and that goes out and does it. As far as latency, and trying to address a few of the things that you had. As far as latency, it's going to differ for different things. For the installation of a new asset, there are pre-drawings that are already created for the drafting of what was planned, and then those are pre-posted. And then when there are red lines to that drawing from the field because of things that they encountered out there that they didn't expect, that we have a pre-posting polygon that says, hey, there's something new going on out here. You need to contact mapping for additional information on this. They can provide you with those records to locate it out. From the time that it gets pressurized, energized, whatever the situation is, those records with the red lines get updated and made available to the locators within a specific period of time. But when there's a change to a map, perhaps a locator goes out into the field, something was installed in the 1960s and documented incorrectly or inaccurately, and they find that out in the field, they are making the update to that, which then gets translated into the GIS system. Those map corrections are handled differently than a newly installed facility. But nevertheless, those GIS records should be updated to be able to make them available, again, to the one constant in this scenario, which is the locator, the end user of this, and then providing that information out. We spent a lot of time talking about the excavator's piece of this, which I think is extraordinarily important, their perception and how they envision what this process looks like. They're a valuable stakeholder. But the truth is that it's the utility operator, not just the private ones like PG&E, but the cities and counties that operate municipal utilities that need to be a voice in this as well. And the louder voice, because they're the ones that are being affected by the installation of this, by their contractors installing these things and providing those records back. So I think we've missed an opportunity to really focus in on what's the process look like from end to end currently for utility operators, and what are the things that are holding us back from achieving what would have to be true from current state to future state, that would have to be true to have everything in GIS, and then what's the level of accuracy that's realistic based on our expectations. We haven't really had that conversation today. I'm getting the eye, I see it now. But I think that's a big point that we've missed today is what is the current process actually look like now? And what would it take to move us to a future state that we all believe would benefit the excavator and the operator?
Thank you. I think you're next.
I see it. So the question that I'm supposed to be answering is how accurate are your accuracy standards? And for us, we have accuracy standards of about 10 millimeters for our utilities. That's less than half an inch for everybody not on metrics. And the way that we're able to achieve that is something that I don't think is in common use or really understood. I think one thing we haven't been talking about is a lot of organizations don't know how to achieve that level of accuracy, and they don't have guidelines to fall back on that are well known and standards that are recommended. So I'm hoping that if you guys do install some kind of regulation, that you're going to provide recommendations for equipment that's capable of reaching those standards, how to get a custom coordinate system from your area, all the things that are needed to get that level. Because technology is changing really quickly. We're in the era of Bluetooth antennas now, and it looks different than old equipment. Like, we're right now trying to find a way to have the integration of all the apps and Bluetooth antennas while keeping our accuracy standards in place, and it's tricky. I think that we all have resource problems trying to get all the things that we need, and it would be really nice to be able to integrate and have everything work together to speed up efficiency and asset management and this and that. But understanding how to have your cake and eat it too, have high accuracy and feasible efficiency with your resource pool is a challenge that most people don't know how to tackle and don't even know how to find the answer for that. I've been to a lot of organizations trying to collect GPS data, and sometimes people are just winging it, trying to figure out how to get that sub-foot accuracy can even be challenging in certain environments, let alone the utility level accuracy that is needed for safety. That's it.
Thank you. So it sounds like West Sac just laid it down. They told us what their current system is. They told us how to do it. So anyone else, because some of the comment I guess we heard was we wanted to not miss an opportunity. Oh, we have someone's with their hand raised to get operators. So go ahead. Who's next?
Looks like we have German Seuss.
Go ahead, Jermaine.
Hey, good morning. My name is Jermaine Seuss. I'm with 811 Northern California. So the thing I wanted to mention today was the accurate facility type information that we can provide in contractor. We just went over GIS is pivotal when it comes to being notified. So on our end at our department, we do manage the operators memberships, try to help them update their mapping boundary, their notification boundary, or their contact information so that the contractors know who to call or reach out to. All of those things need to be accurate for damage to be prevented. But there are some nuances when it comes to facility type information, since EPR has only been around for a few years. But it would be great for the contractors to know beforehand so that that way they can keep track of the assets the utility owner may have, and they can keep track of the markings, keep track of the positive responses that they receive. So that way it matches what they see physically, right? So currently the mapping file that we receive from the utility operators is uploaded into something called a station code. So we used to call it a member code. It's the utility identifier. And EPR in its current form requires the utility operator to provide a response to the 811 center. That should also match what they've located or cleared out in the field. Oftentimes, they only post one response code, such as clear, no conflict, or locate area marked, like per ticket. So those are the two most common ones. And many of the utility operators that have multiple facility types, right, like water, sewer, gas, or if you're a city, they might have streetlights and other utilities, storm drain, right? And they have it all under one station code, which, historically we never really asked them to separate it until EPR came around, where it does cause some confusion to the excavators when they receive an electronic positive response from a company that has multiple facilities, and it just says something like locate area marked, when maybe the sewer line was the only thing that was marked, but streetlights is clear, water's clear, storm drain's clear, but none of that information was sent or included in the electronic positive response. So we have a few solutions that we give to our members where we can separate the station codes. We have one station code for each facility type. That way, if there was a water facility in that area and it was located and marked within the dig site, they can respond to that station code or that facility code, and they can say clear, no conflict, or I'm sorry, locate area marked in that example. And then the other facilities that might be clear of the dig site, they can actually provide a separate response to that station code. And I know I'm getting a little nuanced here. It gets really kind of in the weeds, but when it comes to facility type information, that's something that we receive from the utility operator. It's not always self-evident. We might have a company that says that might be called something water district, but they actually own sewer as well, or storm drain as well. So it's not always obvious. We need that information from the utility operator for them to provide it. That way we can display it on the ticket for the excavator. And, it's one of those things that we have to kind of find those utility companies that still operate under one station code and encourage them to either separate them so that way they can provide a response for each of their facilities separately, or if they want to keep everything under one station code, that might be for a variety of reasons. They might not be able to implement something like that yet. They might not have the manpower to respond to those type of requests, or they might not have the GIS data available to upload a map for each facility type. But long story short, they would have to put something in the notes or separate the station codes, and that's something we encourage. And one of the ways we do that to incentivize them to do that is to not charge them for multiple notifications. So if they receive one ticket and it's a unique ticket, but they have multiple facility types and they were transmitted maybe 5 different notifications because they have 5 different facility types, they're only charged once. So that's currently one of the things that we're in our department going through, reaching out to those members and encouraging them to either post a response for each facility in the notes or to separate their station codes.
Excellent, thank you. So it sounds like there's the call center is bringing up a concern about GIS accuracy for precision and safety on the locator and or at least for clearing a ticket. I have 7 minutes left. Who's next on rapid fire? And I think do we have any more online comments? So if you're gonna speak, please come up so we can. I know how many people are next. Just come up. You can figure out what you're gonna say in a second. Just come on, walk up here.
Okay. I think, personally, I think the best accuracy any department or city can achieve especially when it comes to deliverable, is when, as for example, if we have pipes being laid, before it's buried, I think it should be GPS. I think that's the best thing to do. GPS is top of the pipe, especially on the sewer and the storm drain, and same thing on water lines as well. And sometimes, especially in this part of, especially in UK, let me give you an example. In UK, most of the roads are bent. I think the best thing to achieve the accuracy of anything before it's buried is to shoot the top of the pipe before the curves, it's called BC, before the curves, mid curves, and end of the curves. If you shoot all those points and you have the coordinates, you're going to get accuracy mapping. I think that's what I want to say, yeah. When it comes to mapping, I think that's the best thing to do, yeah, before it's buried.
Thank you.
Thank you.
Any other rapid fire, last minute comments? All right, so we are running low on time, and I do want to just, we have 5 minutes left. I don't see any other, oh, I see Dave Woolley. Go ahead, Dave Woolley, quick.
Okay, there you go. The California Public Resource Code has laws in place that already dictate how to present accurately. I think minimally it needs to be on the same reference frame, and it has to be within 18 inches because that's our trench width by law. Thank you.
Excellent. Okay, so we had a chance to hear from operators, locators, excavators, people that do GIS, people that are in charge of CMMS systems, the call centers, engineers, a whole city almost, right? Great job. But it wasn't enough time. So I think that we have a lot of questions to take back. You guys gave us things to consider. You guys gave us ideas. We're going to take all this out, lay it all out. I'm not sure what the next steps are. Perhaps we'll take all this back and have more an opportunity for another workshop. Either way, I expect we saw 70 people online, about 30 people in person. If you would all attend December 9th and 10th meeting, we'll have more discussion. We'll have more follow-up on this topic because it sounds like everybody is in agreement that safety is a priority. We had some really great ideas on how to make sure everyone was safe in the field. Many of you shared instances where accuracy could help you recover from an incident, prevent an incident, make sure that EMS had access to hydrants. And then there was the ongoing question of what do we do with the assets that have already been mapped and are not accurate? So the locators were asking that. We are still going to do our best case scenario because this rule isn't in place now. This only applies to new assets. And so there was another question of how accurate were they before and how do you match that up? The lats and longs, the monuments, all of these are questions, and there's a lot of discussion to be had. But it was awesome to hear that there was WESAC, again, laid it down with 10 millimeter accuracy. That's pretty phenomenal. So let's give them a round of applause. That's awesome. So with that, I will go ahead and thank you all for being in attendance. I know I had a lot of questions because, as you can tell, I'm very passionate about this because it is our safety and it's everyone's safety. So if there's any ideas that you have, we do have an idea registry. You could be going home tonight, flying home, laying in bed, all of a sudden wake up with a brilliant idea. On our website, we have the idea registry. Please put your ideas in there. It could be like a thought bubble. It could be like remember, this is your world. It could be your world's ideas of every step that we should be following from the design, from the bid, from the build. And we really do want to hear from you because this is an important step for all of us. This is a change. And again, thank you so much, and I will conclude today's meeting. Thank you so much for attending.